Today we are going to perform slope stability analysis of sand and clay embankment by finite element method, that is in RS2 software. This information is obtained from the slide 2 software. I already explained how to import and export data from the one software to another software. By that way, I import data from the slide software. We already discussed in last class. Now we are going to perform the slope stability analysis of sand. To analyze the slope stability, first of all we have to go for the analysis. Then here you can observe this project setting. We have to click on that project setting, click on units. The all units should be in SI unit. Okay. Then we have to go for the stages, add two stages, because we are performing only clay and sand. So first give name as first name is clay. Okay, it seems to be in capital, it will be look good. Clay and sand, so name like that, and click OK. Then go for analysis and project summary. Here you can give name slope stability slope stability analysis. Okay, click on OK. Then next step is we have to click on the boundaries, then add material. So we have to make material, but it won't apply as an materials because already there is a mesh and displacements. We have to remove those things. So then click on OK. It is removed. Then we have to add one partition, because here you can see the embankment and slope which are merged. So we have to give one parting between slope and embankment. So you can here see place. Here you can there is a box, type T and press enter. There is a enter coordinate box. We have to enter that coordinates x and y. Those are 0, 3, and 21. Okay. One boundary is between the slope and clay. So then right click here, you can see done and click on done. It will created a boundary, one parting like that, which separates the slope and embankment. This is about that material boundary. You can see material boundary here. This is external boundary. Okay, I think you got the clarity. Material boundary. Then next step is we have to add materials. Material, minimize it. Properties, go for the properties and click on properties. You can see define materials, then click on define materials. So the first one we have to give name as clay. Change color to okay, ash. Then go for the strength and select more column, already selected. Then material type plastic. Peak tensile strength in kilopascal. Peak tensile strength should be 20 kilopascal. Change into 1 to 20 kilopascal. And peak friction angle is equal to 0. And peak cohesion 20. Then in residual strength tensile strength in kilopascal, that is also 20. And friction and residual friction angle 0 degree. 0, and residual cohesion 20, and dilation angle 0, apply SSR, shear strength reduction. Okay, everything is fine. Then go for stiffness or material properties. Initial condition. In initial condition, field stress. Okay, initial element loading is field stress and body force, and then account of moisture content in unit weight 20 kilonewtons per meter cube. Okay, then there is no change in the unit weight and porosity. Then the second one is stiffness. Poisson ratio should be 0.4 and Young's modulus in kilopascal, that is 50,000 kilopascal. Okay, there is no change in stiffness, and strength we already changed. Hydraulic properties are also same. Datum dependency and stage factors. Okay, no problem. We have created a material property for the clay, and then we have to create for one material property, another material property for sand. Define and clone material to sand, sand, and change the color. So I'm going to change the brown, and click on strength. Here strength Morse coulomb, material type plastic, and peak tensile strength 0 kilopascal and peak cohesion 0 kilopascal. So change it as 0, and this one also 0, and friction angle should be 37. Okay, 37. Next, residual strength residual tensile strength 0, and cohesion also 0, and this will be 37. Both are same. There is no change in the other parameters. And have a look of initial condition. Initial condition that should be changed into 17, and stiffness isotropic. We have to select the type isotropic. Loading Poisson ratio should be 0.4, and Young's modulus also same. And hydraulic properties, have a look of hydraulic properties also same. Okay, click on OK. Then we have to assign the material properties here. So it is you can see the completely the ash color, so it is completely filled with the clay, but we have to change. Assign, you can right click on the slope. You can see here a one box, and you have to click on assign material property, assign materials, and click on OK. It is excavated. So in stage 1 it should be only clay. That's why there is nothing is there here. That's why I excavated it. Nothing is there. So in first stage you can only we have to show clay. Then in second stage we have to create sand, and that means we have to assign material properties as sand for it. Okay, now you can see here only clay, and in sand in stage 2 you can see clay as well as sand. We have to apply material properties and assign material properties like this only. In first stage only clay, and second stage sand and clay. That is very important. If you add both of them here, there will be a cause of data will be changed in data completely. The stress test analysis will be completely changed, because in first stage clay only, then that is sand. Most of the cases we are confusing by adding it in clay. In first stage we are adding both of materials, clay as well as sand. It gives fault results. Okay, I think you are clear about this. Now we have to go for adding one liners and joints. So what is line? Nothing but, so I want to add a one geosynthetic grid, because it gives one shear strength. It restricts flow of sand from the clay. That's why I'm going to add one here, one geosynthetic mesh. Okay, for that, between material, between sand and clay, that is very important to remember. So for to add that one, go for the properties. Here you can see one define liners, click on define liners, then add materials properties here. That here liner type standard beam, not, so we are going to apply geosynthetic. Then elastic properties, the elastic properties, the property should be an elastic and common type, tensile modulus 50,000 tensile modulus, so we have to change it is to 50,000. Okay, then strength properties, material elastic strength properties should be tensile strength. Is there anything here? No. Change into plastic, and tensile strength peak kilonewtons per meter cube, that should be 60, and tensile strength residual kilonewton per meter, that is 0. Okay, set. And next go for the properties, define joint slip criteria. Then here you can click you have to select more coulomb, then tensile strength 0 megapascal, cohesion also 0 megapascal, peak friction angle, that should be 30 degrees, change into 30 degrees. And next, okay, these are the properties of joint. Then you can see here stiffness, the stiffness should be the same, and click on OK. Here you can check the liners and joints. Again go for the properties, and here you can see define structural interface, click on that. You can see in structural one, that is joint and liners, everything is okay, and joint side, then click on OK. Then next step is go for the boundaries. Then we have to add this liner and joints between the slope and that is sand and clay. So for that, go for add structural interface, click on add structural interface. Here we created a liner and joint. Then the first point closed, you have to select first point closed and last point open. Then install at stage 2. So in stage 2 we have to install that, because in stage 1 clay there is no sand, that's why we are selecting only in stage 2. Then click on right click, then click on OK. Here you can see plus symbol. Then you have to enter or type T in the box that you can see in right corner box, then press enter. We got a coordinate box, then enter the coordinates of that joint 3, 0, 3 and 3 and 21. Okay, these are the coordinates of the material boundary, and click on OK. It is add. You can see here one liner is going to add, then right click on that, then you can see done, click on done. We have added material boundary, that is geosynthetic mesh. Okay, this is sand, this is clay. Now we add the material properties and everything. Then we have to add mesh. So find the next step is mesh. Here you can identify mesh setup. Okay, then approximately number of mesh elements. If you, this should be less 800. If the elements approximate if elements increases, the time of analyzing increases, because the elements, if you increase elements, accuracy will be increased, but also to get accuracy, time will be increases. That's why I am changing to 800. I don't want that much of accuracy. It will, if you want to see, just you have to keep it at 3000 to 5000, then check how much time is taking to analyze the data, and change to 500 200. Let's check the timing period for the analysis. No problem for depending our time. Then I'm going to change that value from 3000 to 800 or 500. No problem with that. Then click on discrete, and you can see mesh. Then click on mesh. Okay. Completely the mesh tool is applied here. So we have to add boundary restraints. So these are the rigid boundaries. So I want to change the rigid boundaries into one flexible boundaries like rollers. Then go for the, to change that one, go for the displacements, click on displacement. Then click on resistant x-axis, that is resistant x. Then click here x, and here, then click on apply. Okay. Next, go for again displacement. So there is one problem, directly we can here choose the bystands also, but I am recording now, so unable to see here. That's why I am again going to the displacement and click on restrain y. Again restrain y. Then here you have to click on the bottom. Okay, then click on apply. Okay, the rigid boundaries are changes into the flexible boundaries. Then we have to add nodes. Here we have to add nodes. You can see here. So first of all, boundary elements are there now. We have to change into boundary nodes. Then choose it, and we have to click on the edges, vertex of the slope. Okay. I think I don't need that one. Here, and here. Okay, then apply. Okay, you can here see this is a rigid one. Nodes, these are all our nodes. Everything is perfect. Then click on apply, close. So finally we have done meshing and displacements, and we added the restraints. Then the last step is analysis. Go for the analysis. Here you can see compute. We have to compute it. We have to save. If you add 3000 elements or 6000 10,000 elements, it takes much time, but I given only 800 elements, so it takes some time. You can also change to 3000. You can see the how much time is taking to analyze. No problem with that. Okay, but we get accuracy. We need accuracy, then we have to wait, we have to work hard. strength reduction factors. These are the it will increases the strength from the 0.1 to 1. Okay, done. Analysis done. So now ready to interpret. Then click on analysis. Here you can observe the last one, that after the compute. Then you can see interpret. Click on it. Okay. Then if you want to move the slope, then click on pan, right click on the slope, and you can see the pan, or directly you can enter the F10. We can move. Okay, so this is the ultimate analysis. So if you want to know the sigma, that major principal stress here, this is major principal stress 165.61, and here that is red zone, and sigma 3 minor principal stress is 111.16 kilopascal. And if you want to know about the solid displacement, that is total displacement is 0.0049. Displacement will change, but here you are not unable to see that clay and sand stages. To identify those things, go for the view data, go for data, click on data. You can here see stages, stage setting, click on that one. Here reference stages. So if you change to initial point, then here you can also drag to SRF, strength reduction factor, stress reduction factor, RF1, then click OK. Now you can see here clay and sand. If you select clay, then the displacement is 1.1, then sand, SRF, these all are the stages. Just in SRF, stress action 0.49, this is the displacement, and like that this is SRF1 0.49. These are the stages. You can see fluctuations. And let's see for the strength factor, that is factor of safety, strength factors. Okay, let's see. In clay you can see 5.68, that is factor of safety is high, more than 1. But come to sand, the factor of safety just sorry, if you click, everything is blue in clay, that means 5.68. but come to sand, the factor of safety or strength factors as varying is completely yellow color, that means it is between 1.262 or 0.95 to 1.6 and 1.58. so this is the factor of safety of the sand. So if the stress factor is increases, then what happens? Strength is decreasing. Okay, this is about the factor of safety. And you can here see the displacements. Okay, strength we already seen sigma 1 here, principal stresses in clay, sand, and increasing the stress, what happens? Principal stress is also increasing. Okay, this is about the analysis of sand and clay of that is we are creating one slope on clay embankment. By that way we can study the stresses and also factor of safety, and some changing in displacement, that horizontally, vertically. There are many analysis factors are there, like solid effective stress. Here you can see sigma 1 and sigma 3, like that, and solid total stresses, yield elements, solid displacement, strength factors, like that. So this is about the experiment we have done analysis. Okay, thank you.